All right.
What's up, dude? How you doing? The session is about to start. Give it just a second, and we are live. I think
All right.
so. Vinoth, I'm excited for your talk. Every time that I chat with you, I really enjoy everything that you have to say. I feel like you bring a different dimension and perspective. You've got the first keynote. Gonna give it up strong. I'll let you take over. I'm gonna bring your slides up onto the stage, and I'll be back in 20 minutes.
All right. Thanks for that, Demetrius, and thanks for having me. Hello, everyone. Welcome to the first of many OpenX data conferences. We have an exciting day in store for you, as Demetrius went over that. I'm Vinoth Chandar, founder CEO of OneHouse. I lead some major open source data projects. I build large scale data infrastructure at Uber and LinkedIn before this. Today, we're going to kick off with a deceptively simple but a very fundamental topic on open data, how we can use the right tools to build your data platform. Let's start by reviewing the state of affairs for cloud data. There's a lot of time and effort spent in a very large market. Right? Just two popular cloud data platforms have over 1,000 companies spending more than $1 million on their cloud data platforms. And companies, predominantly start their data journeys on a single engine, typically a warehouse. And but many of them now 1/3 are doing other use cases than BI, like data science, ML, and all of that. And your first engine kind of starts as your foundation, but in many of these cases there's the feeling that it becomes a ceiling for what you can achieve with your data. And as the AI projects are exploding, lock-in remains a top three concern across the board, and issues like privacy, data sovereignty, and flexibility to bring these rapidly evolving new set of tools for AI to your data remains a top concern. There's a general feeling that cloud data is expensive. It lacks flexibility and is prone to lock-ins. And I think this is due to something I call the engine first trap, right? So the first simple thing, and it's like that many companies do is they focus on a single engine too much, right? Without considering their data and the use cases that they are going to have just the next year or 2 years out. And data has immense gravity, right? So when you start building your data warehouse and start storing data into it, but then this data gravity pulls queries to it, access to it, and before you know it, there is you kind of have a lot of data in a single system that you're struggling to bring new use cases, better engines, even if they exist in the market, right? And at that point, it's pretty hard to consider a migration because, again, the data has inertia. So then there's this typical pattern, right? You double clicking one level down. So you pick the engine, essentially did whatever the vendor recommended around formats, tools, and whatnot. But the minute you try to bring a new engine, you hit a lot of these issues because it's the data format is either incompatible or it's inefficient when you access to the new engine, and it's expensive to migrate data over, right? So I know of companies who spend millions and sometimes tens and millions of dollars, single compute platforms, plan a migration project every year and make like 20% progress, right? So this is like a very big decision that shouldn't be made very lightly upfront. But if you look at where the world is right now, it's actually in a different place, right? And it's moving rapidly towards a different direction. So there's this thing called a Cambrian explosion, so which is a period in the Earth's history where a lot of new species and life forms emerge at a very rapid pace. So we're kind of living in something like that around when it comes to cloud data ecosystem, right? So there is a lot of different specialized engines. Often, they can all read data in open formats, and they are replacing this like one size fits all model that we had for decades, right? And as a whole, the database industry, open source software is outpacing closed source databases significantly. It officially crossed over a couple of years ago. So the actual Cambrian explosion in nature, right, that was caused by kind of change in oxygen levels, right? So Likewise, this is not an accident, right? There are seemingly small but very profound factors at play here that are helping, and furthering this kind of shift. Let's examine them first. So first, cloud is now de facto data storage, right? So in the cloud, everything is on demand storage, on demand compute. You pay for these two separately. So you can have a world where you're paying for your ingestion ETL vendor separately and your query engine separately, right? And as a technology, data lakes and data warehouses are converging. And this is one area where I spend a lot of my last 7, 8 years on, which is, to blur these lines between these two main storage models. And cloud storage on the whole is getting faster and faster, which unlocks new possibilities for us. And the rise of open table formats like data warehouses are finally opening up to open formats like Apache Iceberg, other table formats. This actually, makes it, eliminates these islands that you build and start with. So you no longer have to build an island for BI and then think about the broader ecosystem. You can start open. Right? And we ask this question at most conferences that we go to, right? Which is, hey, what do you use? Right? So from open source to commercial engines, and you can see, right, that there are plenty of companies who are using, like, there are a lot of engines in use in this market, and even within the a single engine, right? For example, Spark is a very popular engine. Even that engine is bought in a bunch of different ways, right? People like to do it themselves. People like to use something like EMR provided by a cloud provider, or other vendors around the thing. So and no engine is best on every workload. And I think, we've done a lot of research around this, compared engines across these different data use cases, analytics, data science, machine learning, and stream processing. You can check out these QR codes and, go check out your blogs. We've gone very deep and compared, for example, engine design, vectorized processing, push versus pull based processing for analytics engines, and for ML and data science, how well do they support GPUs, Python support, things like that, right? So there's a reason for all these engines to exist. They do certain things really well, and your data should be, kind of you should be able to leverage this on top of your data, right? And the other thing is performance and TCO, total cost of ownership. This is another key aspect, right? So the engine that you pick fundamentally affects your teams and companies' budgets, as simple as that. So, for example, ETL pipelines are the lion's share of your cloud data costs. And as a vendor, we focus on ETL workloads, right? And we announced our engine Quanton yesterday that focus on lowering the TCO for these workloads. A general comment is we generally distrust, frown upon benchmarks. There are valid reasons, since benchmarks have been used in certain way by vendors in the past. But learning to benchmark for yourself on your own workloads, on your own data, is very important skill, because cloud data workloads cost serious amount of money. So again, engine choice matters. So now that we've established that there are strong reasons for thinking beyond a single engine, or at least be very mindful when you pick your first engine that you don't want to close any doors, right? You want to preserve the modularity or the optionality to bring other engines to your data. Hopefully that's pretty clear. And the fix is actually very simple. It's not going to blow your mind. It's just that it's super challenging to implement in practice, as we'll see in later slides. But the basic idea is you store data in only in open data formats, right? Like avoid any kind of closed data format storage, put it on like cloud storage, and then try open source engines on top of your data, right? So understand your data, evaluate needs and gaps, see where it falls short, what kind of access patterns do you have, what's the shape of your data, take the time to actually understand your data, right, using open source engines, and you still haven't made your any your commercial decisions yet, right? And once you know these gaps, you can then move to places where you need commercial solutions, right? They exist for good reasons. You can kind of upgrade to them, fully understanding what OSS cannot solve for you. The simple principle here is migrating data is extremely hard, right? As we saw before, but comparatively, switching engines is like relatively easy, right? When once you adopt this kind of model. And this is a tried and true approach. I worked in two-thirds of these companies that are shown here in this table, and the common pattern here is you put data on like open formats, open file formats, table formats on horizontally scalable storage, and you use different engines for different use cases, from like ETLs or warehousing, interactive analysis, and data science. Um, but why is this not happening everywhere, right? Because it does take a village to do this, right? So we all these companies have a deep engineering bench with a lot of engineers to actually go build this, but not every company has the time, or not every company is organized in the same way, right? So even this table here shows for a cluster size, the amount of work that you need to do something in production, right? You can obviously spin up something on your dev environment or play with it, but this is what it takes for you to go live, right? And on top of this being hard for the users, this is not how the ecosystem works today, right? So the all engines want to be best for everything. So every engine claims I'm good at everything, right? So they're less incentivized to make this multi-engine experience like a primary thing, right? Even though that benefits the users a lot. And a lot of these managed services in open source are sold on these like very gaps, right? And for example, you on the right you can see, right? I mean, you have open source core, and then you sell upgrades, some managed catalogs, access control, optimizations. These are the very things you lack to go to production easily on open source software is what you're also typically sold in managed services. And if you look at things like warehouses, they still default to closed formats, right? So they're not incentivizing the move to, okay, start on an open format, right? They default to closed. Open is like a optional thing that you can use if you want. So this increases the cost of switching, right? And there should be a core set of services that should remain interoperable. You should make sure your file, table format, table optimization, catalogs can be switched at any point in time, right? If you can achieve this, other than this, you can totally implement this model to it. But what if we could make this even more easier, even more accessible? What if we had an open switch, right? Moving from the engine first model of, kind of like limited choices, proprietary things to data first model, open formats, sync to multiple catalogs, and query with the engine of your choice. So this is at the core of this company that I founded called One House. And we recently built this thing called One Open Engines to address this head on. So what is this? So essentially, it gives you very easy ability to spin up, purpose-built engines on top of the same copy of data for different use cases. So you can bring, data ingested by open source or managed tools, put it in open data formats, and essentially, it provides all the essential services for you to go to production. For example, it can sync with multiple catalogs. It does basic things like, we maintain the clusters, the auto scaling, right? So we just made it easy if you are not one of these companies who have a lot of engineering resources to get started on this open, data first model. This is something that should make your life easier. And this is how we think it flips the defaults to open. So first, consciously, it's priced lower than self-managed OSs, right? And you use it with the exact same open source tools. You get the same exact community support. So nothing's really changing. All it's doing is making it easy for you to connect your data to these open source engines and get something basic for you to go to production with. And it eliminates a couple of lock-in points around storage optimizations, right, that exist. And because a lot of these engines are also bundling storage optimizations with the engine, which is great, but it also creates a lock-in point, right? If you move to the second engine that's not optimizing it in the same way, query performance suffers. So we're eliminating that, made it work with all catalogs, so your permissions will translate when you switch engines, switch catalogs, and you can seamlessly upgrade to commercial engines, right? This is not to say that, oh, don't use any commercial engines. It's basically flipping the model to like go methodically layer by layer. And here is how generally, One House can help. First of all, we don't have, we just build it together, right? We are open source contributors. We build a bunch of open source projects. We contribute to a bunch of open source projects, so we can be in these communities. You can just use these open source tools and build it yourself. If you're interested in this like data first approach, OneHouse can with has managed services like I just showed. Just pairing an ingestion service and open engines together can help you ingest some data, put it in front of open source engines and commercial engines at the same time. So you can benchmark side by side, you can compare apples to apples and make a very educated decision for what engine you want to pick. And obviously, we have the most open cloud data platform. We have broad interoperability across both open source commercial ecosystems, and we can run a lot of your core workloads right away. Right. So with that, some final takeaways today is specialize deliberately. No single engine is good at everything, right? And I think in today's world, we should be able to match engine to specific workloads because the data scale is high. We're spending a lot of money on these workloads. Number two, open formats give you a lot of flexibility. Combined with open services and portability across catalogs and things like that, it creates a really good architecture model where you can not be doing these data migration projects. And data has gravity. Choose wisely. Yearly editions are critical, and do regular assessments to make sure that your data architecture is actually your stack is up to date, right? All right. With that, I thank you all for being here for this talk. There's a lot of fun talks in the conference area today, and also be sure to tune into the panel on open data platforms later. That's going to be fun, and we're going to touch upon a lot of these aspects in the panel as well.
Right on, my man. That was great. Okay, so we've got a lot of questions coming through in the chat, and I am sure that people are going to be asking away as time keeps rolling. Let me start with the question that is on a lot of people's minds, which is, yes, all of this will be recorded and we will be giving the slides to you. So we'll have the replay going for the next 24 hours, and we will be packaging up these individual talks and then throwing them onto the OpenX data website so that you can watch it at your leisure. Now, to the real meat and bones and the questions for you, Vinoth. What is the ideal cost-effective analytics engine setup?
That's a great question. And it's something that is also a little bit subjective, right? So I will say my piece here. So I think for analytics specifically, honestly, if you have small amounts of data, start with something like Postgres, right? And outgrow something like that at like a TB scale or something. I think you will start to see. So, and for then get your data like I was talking about in an open like an open format on top of cloud storage, connect things like open source, Presto, Trino, Star, all these different engines in our analytics guide, evaluate the performance. I think you will find that you get great performance on cost price performance on top of that. Then if your queries are complex enough, then start trying warehouses and more specialized systems around these. And somewhere in between, if you like, the open source engines are good enough, but I don't want to manage them, there are plenty of managed services in between, right, that can actually help you with the operational aspects of it.
I was just choked on my drink. That was a great answer. Let me compose myself here. All right. So OneHouse is open sourced and able to be self-hosted?
Good question. So OneHouse is a cloud SaaS service, and it's self-hosted in a sense that it's BYOC serverless model. We run in your VPC, so it's almost like you're self-hosting it, except we are doing all of the management, cluster management, all of the. So the operations is handled by us, right? So that's the model. The managed service is not open source, but we are completely built on open source technologies. ground up. So if you go to like a website, you can find the open source stack that we use. What open source OneHouse provides on top of these open source projects is actually making it very workload aware. They're making all these like dynamically work for your specific workloads, right? For example, it can adapt to lags in your data pipelines, stuff like that, right? But we build on open source software completely.
Excellent. Now, are there any opportunities for integration between OneHouse and Dagster? I see that Snowflake is a first-class citizen, but not OneHouse.
We love to integrate across the ecosystem, right? So here's the great part about this, right? And goes back to my open stack. We are built on open technologies answer. You can use Dagster today and submit, like say, if you're doing DBT, or if Dagster integrates with DBT and Spark, right? So you can use the same exact integration against our Spark and SQL, clusters that we announced yesterday. So we don't have to build a special. We could build a special integration, but we don't really require it. Like you can use Dagster probably on top of us. Like we can use Airflow. So I'm basically based on that, I think Dagster would work as well.
All right, last one for you. Is OneHouse both OLTP and OLAP engine?
No, we are not an operational system. So OneHouse is more for OLAP or analytics. But while I say that, I'm passing because the world's way more complex than OLAP for data, right? So OLAP is BI, right? Predominantly, that's analytics is what it means. But OneHouse, what it unlocks is it unlocks use cases beyond that. It can go beyond analytics and unlock data science, machine learning use cases, stream processing use cases, and much more, right? But we are not on the OLTP operational database category.
Holy smokes, I said one more question and then there was like 5 more that came flying in. So how is OneHouse used in real companies? What makes it different?
What makes it different? Great. So the common pattern that we've seen for OneHouse usage is you have a warehouse or like a single vertical system, right, closed or open, and people actually want to move towards this model of, okay, I want my data to be in open format horizontally, and I want to use, for example, still want to use my warehouse for my data analysts want to stick on warehouses, my data scientists want Spark notebooks, and I want to use interactive query engines in between to power some operational dashboards, right? So that is the sweet spot, and OneHouse uniquely unlocks that architecture while making sure this engine flexibility remains intact. And also when it comes to these ELT, ETL workloads, we run all kinds of ELT, ETL workloads, pipelines. We can do that at a way better cost price performance than other tools in the market.
All right. Brian's asking an amazing question here. I might need to give away some swag for this question. Any proven strategies for convincing non-data first companies with limited data engineers that an open data architecture is better than closed compute engines? Difficult to ask non-data engineers that a complex OSS data versus a one-stop data warehouse.
Yeah, great question. I assume if you are, for example, a tech lead or like a senior IC or like a manager looking to do this, so here is what you do. You point to your management how look at the big five, the three clouds, Databricks, Snowflake. There are everybody's talking about open table formats, so open lakehouses. This is the mainstream. The industries agreed on this as the way forward, and there are lots of work. There are new open source catalogs, right? There are new table formats and file formats being born. So if you point at all the vendor ecosystem where it's going, it's clearly going towards an open open data first architecture, right? The other thing that you point to is look at what all the data forward companies have built. Like that was the table that I showed. You can find it in our Open Engines blog, right? There are countless examples. There's just included three things, but there are like so many examples of companies who kind of benefited from building that way. At that point, what you'll find is the gap is merely that, okay, this is the right thing to do, everybody's aligned, and lots of companies with deep engineering pockets have done this. The gap is how do we do it, right? So that is basically why we built Open Engines, because we see this gap. I was on these teams at Uber and LinkedIn, and we had engineers to go build it, but I see this like day in and day out in my life here as like a, like a leading a like a data vendor, as a data vendor, that a lot of our customers that we work with, that gap is what prevents them from making the leap.
Yeah, if everyone could be as privileged as the Ubers of the world that have all of those resources to throw at the data teams, right? So, great answer. Well, man, Pavan asked another awesome question, but I think we got to cap it because I have one job today, and that is keeping time. You can call me Ringo Starr. I'm going to be the one who makes sure that we run on time. The trains have got to go. So, Vinoth, this is excellent. I imagine you can go and jump in the chat and answer some of these questions.
Yes.
Thank you, everybody, for the awesome questions. And Brian, that was such a good question. I appreciate that, man. Hit me up. I'll send you some swag. Now, we've got Shelby coming up. Let's get you out of here, Vinoth. And we will be going to our next